You have a fruit tree that's been sitting in your yard for years. It leafs out every spring, looks perfectly healthy, grows taller every season, and produces absolutely nothing. No flowers, no fruit, just leaves. You've watered it, fertilized it, pruned it, talked to it, maybe even threatened it. Nothing works. Now imagine someone hands you a nail, a single, ordinary nail, and tells you to drive it into the trunk. Your first instinct is that this person is insane. You're going to wound a living tree on purpose? That sounds less like gardening and more like an act of frustration. But here's what they don't tell you in any gardening magazine, on any fertilizer label, in any advice column sponsored by an agrochemical company. That nail might be the only thing that actually works. Not because it's magic, because it's biology, because somewhere inside that tree there is a survival switch, and that switch has been waiting for a signal that only stress can send. This technique has a name. It has a history that stretches back centuries across Japan, China, and the Mediterranean. It has peer-reviewed science behind it, and it costs you approximately the price of one nail and 30 seconds of your time versus the $40, $60, sometimes $120 bottles of professional flowering stimulant that the $8 billion plant nutrition industry would much rather you keep buying instead. Before this video ends, you're going to understand exactly why your tree refuses to fruit, what that nail actually triggers inside the tree's vascular system, and how to do this correctly so you stimulate reproduction instead of killing the tree. Stay with me, because the science in the next section is going to completely change how you think about every plant you've ever grown. Let's talk about who benefits from you not knowing this. The global plant growth regulator market, the industry that sells flowering stimulants, fruiting boosters, hormone sprays, and bloom-enhancing fertilizers, was valued at $8.1 billion in 2023, according to Grandview Research. By 2030, it is projected to reach $13.2 billion. That is not a niche market. That is a systematically built dependency, and you are the target customer. Every year, home gardeners and small-scale orchardists pour money into products with names like Fruit Fuel, Bloom Booster Pro, or Flower Force, products that contain synthetic auxins, cytokinins, and gibberellins, which are laboratory-manufactured versions of the exact hormones your tree already produces on its own when it feels threatened. Read that again. They are selling you a synthetic copy of something your tree makes for free. The moment it believes its survival is at stake, the comparison is almost insulting. A 250 ml bottle of commercial flowering stimulant retails between $35 and $80 at most garden centers. A box of galvanized steel nails costs under $2. One nail is all you need. The active mechanism is not in the bottle. It is in the tree waiting to be unlocked by the right biological trigger. Now, to be fair, in this matters, commercial plant hormones do have legitimate applications. In large-scale commercial orchards managing dozens of varieties across hundreds of acres, precision hormonal application gives growers control that a nail cannot. This technique is not a universal replacement for every situation. There are tree species, soil conditions, and growth stages where mechanical stress intervention is inappropriate or ineffective. And we will get to exactly those limitations before this video is over. But for the average person with one stubborn fruit tree in their backyard, the $8.1 billion industry has very little interest in telling you that the answer might already be sitting in your toolbox. The question is, where did this knowledge come from? Who used it first, and why did it almost disappear entirely? The answer goes back further than you think. This is not a gardening hack someone invented on the internet. This is ancient knowledge that survived for centuries and then was quietly buried. The earliest documented references to deliberate mechanical stress on fruit trees appear in Roman agricultural texts. Columella, writing in approximately 60 AD in his work De Re Rustica, one of the most comprehensive agricultural manuals of the ancient world, described the practice of wounding unproductive trees as a method of forcing fruit production. He wrote about farmers driving copper implements into the bark of stubborn figs and olives, not out of desperation, but as a calculated, understood technique passed down through generations of Roman horticulture. This was not superstition. These were working farmers recording what reliably produced results. The same principle appeared independently across East Asia. In traditional Japanese orcharding, a practice called kankoku involved controlled wounding of trunk tissue in trees that had grown vegetatively dominant, meaning trees that kept pushing energy into wood and leaf growth rather than reproduction. Chinese agricultural manuscripts from the Song dynasty, roughly 960 to 1279 AD, reference scoring and piercing of fruit tree bark to redirect the tree's vital energy, a concept framed in the language of traditional medicine, but describing a biological reality that modern plant physiology has since confirmed with precise molecular detail. For nearly 2,000 years, this knowledge lived in the hands of farmers. It was passed from father to son, from village elder to apprentice, embedded in practical tradition rather than academic literature. It did not need a laboratory to validate it because the orchards themselves were the proof. Then came the mid-20th century. Between 1950 and 1970, the global agrochemical industry underwent an explosion driven by post-war synthetic chemistry. Hormone-based agricultural products flooded the market. Extension services funded by chemical companies promoted spray-based solutions. Traditional mechanical techniques were not disproven. They were simply never mentioned again. The economic incentive to teach a farmer to use a nail instead of a bottle was exactly zero. The knowledge did not die. It just stopped being taught. And that distinction is everything, because what was forgotten can still be recovered. And the science that explains why it works is more fascinating than anyone in that $8.1 billion industry wants you to sit down and actually read. Here is what actually happens inside your tree the moment that nail breaks the bark, and why it triggers one of the most powerful biological responses in the plant kingdom. Your fruit tree has two primary vascular systems running through its trunk. The first is the xylem, which carries water and dissolved minerals upward from the roots. The second, sitting just beneath the bark in a thin but critical layer, is the phloem. The phloem is the tree's nutrient highway. It moves sugars, amino acids, and signaling compounds produced in the leaves downward through the entire plant. When you drive a nail into the trunk, you create a localized disruption in this phloem layer. Not a severance, not destruction, a disruption, and that difference is everything. The moment phloem tissue is damaged, the tree's signaling cascade begins within minutes. The first responders are jasmonic acid and its active form, jasmonol isoleucine, a class of plant hormones collectively called jasmonates. Research published in the journal Plant Cell and Environment has documented jasmonate synthesis beginning within 30 to 60 minutes of mechanical wounding in woody plant species. Jasmonates are the tree's internal alarm system. Their primary function is stress coordination. They travel through the vascular tissue and begin reallocating the tree's metabolic priorities away from vegetative growth and toward reproductive output. This is not metaphor. This is measurable biochemistry. A tree that has been mechanically stressed shows statistically significant increases in endogenous ethylene production within 24 to 72 hours of the wound event, according to studies on stress-induced flowering reviewed by the American Society for Horticultural Science. Ethylene, in this context, acts as a secondary messenger that directly promotes floral initiation, the biological process of converting vegetative buds into flower buds. The tree is not confused. It is executing a genetically programmed survival protocol that evolution has refined over millions of years. When the organism detects structural damage that threatens its continuity, it accelerates reproduction before the threat can worsen. The underlying logic is brutally elegant. A tree that believes it may die has one biological imperative: produce seeds before it does. Flowers become fruit. Fruit contains seeds. Seeds carry the genetic legacy forward. The nail does not trick the tree into doing something unnatural. It activates a pathway that was always there, waiting for the right signal. You are not forcing the tree. You are speaking to it in the only language its nervous system understands, the language of survival pressure. There is a secondary mechanism worth understanding. When phloem flow is partially interrupted at the wound site, sugars produced in the canopy begin to accumulate above the disruption point rather than flowing freely downward. This local sugar accumulation is itself a flowering trigger. Research from Wageningen University in the Netherlands, published in 2018, demonstrated that elevated soluble sugar concentrations in shoot tissue directly upregulate the expression of phlorogen, specifically the FT protein, which is the primary mobile flowering signal in most angiosperm species, including all common temperate fruit trees. In plain language, the nail creates a traffic jam of sugars, and that sugar accumulation chemically tells the tree it is time to flower. Two independent mechanisms. One nail, the jasminate stress cascade, and the sugar accumulation pathway converge on the same biological outcome. Floral initiation in a tree that had been stubbornly vegetative. This is why farmers across 2,000 years and multiple continents independently arrived at the same technique without ever speaking to each other. The biology was always consistent. Only the explanation was missing. And the explanation, as you are about to see, comes with specific conditions, because this technique has real boundaries. And understanding those boundaries is what separates someone who uses this correctly from someone who kills their tree trying. Before you pick up that hammer, there is something this video owes you. The part most forbidden knowledge content deliberately skips because it makes the technique sound less miraculous than the thumbnail promised. This method has limits, real ones. Mechanical stress induction works most reliably on temperate palm and stone fruits: apples, pears, quinces, plums, cherries, and peaches. These species have deeply conserved jasminate stress-to-flowering pathways that respond predictably to phloem disruption. A 2021 meta-analysis published in Scientia Horticulturae, reviewing stress-induced flowering across 34 woody fruit species, found statistically significant flowering responses in 78% of temperate tree species tested, but only 41% of tropical and subtropical species showed consistent results under the same mechanical stress conditions. If you are working with mango, avocado, or citrus, the nail technique is far less reliable and potentially more harmful because these species have different vascular architectures and hormonal flowering triggers that respond better to temperature differential and photoperiod manipulation than to mechanical wounding. There is also an age and health consideration that matters enormously. This technique is designed for mature, healthy trees that are vegetatively dominant, meaning trees that are growing vigorously but refusing to flower despite having reached reproductive maturity, which for most apple varieties is between 3 and 8 years from grafting, according to the University of Minnesota Extension's Orchard Management Guidelines. If your tree is young, recently transplanted, diseased, or already under drought or nutrient stress, adding mechanical injury does not activate a survival reproductive response. It compounds existing stress and can open infection pathways that damage or kill the tree. A wounded tree that is already struggling is not a tree that flowers. It is a tree that dies. This is the part the $13.2 billion industry gets right, even if their motivation is commercial rather than educational. Stressed trees need careful management, and intervention without diagnosis is gambling with a living organism. So here is the identity shift this requires. You are not a person who applies techniques. You are a person who reads their tree first. You observe whether growth is vigorous and vegetative. You confirm the tree has reached reproductive maturity. You assess whether it is healthy enough to treat a wound as a signal rather than a threat. That shift in how you see yourself, from applicator to diagnostician, is what separates someone who gets fruit from someone who gets frustration. Once you have confirmed your tree is the right candidate, the execution is straightforward, precise, and genuinely takes less than 2 minutes. And that is exactly what comes next. This is where 2,000 years of accumulated knowledge becomes something you can do this weekend. Timing is the first variable, and it is non-negotiable. You want to perform this intervention in late winter to early spring, approximately 2 to 4 weeks before your tree's normal bud break, the point when dormant buds begin to swell but have not yet opened. In most temperate northern hemisphere climates, this window falls between late February and early April, depending on your specific variety and local conditions. The University of California Cooperative Extension's Orchard Management Calendar identifies this pre-bud break window as the period of highest hormonal sensitivity in deciduous fruit trees, meaning the jasminate and ethylene cascades you are triggering will have maximum influence over whether forming buds differentiate into flower buds or continue as vegetative shoots. The nail itself matters more than most people assume. Use a clean, bright steel or galvanized nail between 60 millimeters and 80 millimeters in length, roughly a 10 to 12 gauge construction nail. Before anything touches your tree, sterilize the nail completely. Wipe it down with 70% isopropyl alcohol and allow it to air dry for 2 minutes. This step is not optional. An unsterilized nail introduces fungal spores and bacterial pathogens directly into living vascular tissue, and fire blight alone, caused by Erwinia amylivora, can devastate an apple or pear tree within a single season. 30 seconds of sterilization protects years of growth. Choose your insertion point on the main trunk or a primary scaffold branch, positioned at approximately 30 to 45 centimeters above the soil line. Avoid existing wounds, pruning scars, or any tissue that shows discoloration. Drive the nail at a slight downward angle, approximately 15 degrees below horizontal, to a depth of roughly 2/3 of the nail's length. You are targeting the phloem layer just beneath the bark without driving through the entire trunk. One nail on a trunk with a diameter under 15 centimeters is sufficient. For larger, more established trunks above 20 centimeters in diameter, 2 nails placed on opposite sides of the trunk, 10 centimeters apart, creates a more complete phloem disruption without overstressing the tree. Leave the nail in place. Do not remove it. The tree will begin compartmentalizing the wound within days through a process called coat it. Compartmentalization of decay in trees, first described by plant pathologist Dr. Alex Shigo in the 1970s, and the ongoing mild disruption sustains the hormonal signal through the critical flower initiation period. Within 3 to 6 weeks of bud break, you should see a measurable difference in bud development. Within one full growing season, a tree that has spent years producing nothing but leaves will show you what it was always capable of. Stop. You just learned something that a multi-billion-dollar industry spent decades making sure stayed buried in old Latin agricultural texts and forgotten Japanese orcharding traditions. Not because it is dangerous, because it is free. A single nail. 2 minutes of your time. The activation of a biological pathway that evolution spent millions of years building into every fruit tree on this planet. That is what they do not want you to know. Because every fruit tree you fix with a nail is one less customer buying a $60 bottle of synthetic hormones from a $13.2 billion market that runs entirely on your dependency. So if this video reached you, do not let it stop here. Share it with one person who has a stubborn fruit tree sitting in their yard going nowhere. Not because you want to help this channel, but because spreading this information is a small act of resistance against an industry that profits from keeping growers dependent, confused, and reaching for their wallets instead of their toolboxes. Subscribe not as a gesture of support, but as a commitment to keep receiving knowledge that was never supposed to reach you this easily. And in the next video, we go deeper. There is another technique, even older than this one, that Japanese farmers use to double fruit size without a single gram of fertilizer. The industry really does not want you to see that one.